Okay, so let's look at number 5. It says simplify the following trigonometric expressions. All right, so when you see this and you're simplifying, a very first good rule 1 to go off of is to change everything to sine and cosine so that you can start canceling. So I'm going to go ahead and start recopying this. I see that I have cosine of x, whoops, and then I also have secant. So this secant here is going to change to 1 over cosine. Okay, and then there's multiplication occurring there, and then cotangent down here is going to change to cosine over sine. And now I want to see if I can start canceling and reducing all these fractions. You see cosine and cosine cancel to a form of 1, because if you didn't know it already, this cosine here that's standing all by itself is the same as cosine over 1. So remember, when you have a piece that's on top in the numerator and on the bottom in the denominator, between multiplication of two fractions, they will cancel to a form of 1. So all that I have left up top is just 1. And now I have it over cosine and sine. So I have something that looks like this. 1 divided by that huge fraction. So 1 divided by cosine over sine is the same as from 5th grade math, keep, change, and then flip. So we get sine over cosine. Well, we know 1 times sine over cosine is still sine over cosine. And we know by now that sine over cosine is the same as tangent. So that's what we're trying to do. We're trying to simplify to the most simplified version of what we get. And of course, fractions that are gone, and we just are left with tangent, that's the most simplified form. Let's go to part B. This tangent is going to change to sine over cosine. Okay, it's multiplied. This cosine is going to change, or not really change, but we're going to write it as cosine over 1. And then last but not least, cosecant is the same as 1 over sine. Now you can treat this as one huge fraction because it's being multiplied together, and anything that's multiplied is basically saying all of this is the same monomial. It's the same one-term piece that just has different trigonometric functions within it. So because multiplication does glue all these pieces together, we know sine and sine will cancel. We know cosine and cosine will cancel, so that it's simplified just to 1. Let's look at part C. Okay, so we have a big fraction minus another big fraction. I'm going to change this cosecant up top to 1 over sine. This sine on the bottom, I'm going to keep as sine. And now I'm going to change this cotangent up top to cosine over sine. Again, remembering that we're trying to change everything to sine and cosine. And this tangent is sine over cosine. Alright, so I have 1 over sine divided by this sine of x, which is the same as keep, change to multiplication, and then flip the sign. So sine of x, if I flipped it, became 1 over sine of x. Okay, and some of you can already see this earlier and just see that this is going to become 1 over sine squared. Okay, let's go to the next one. We have over here, we have cosine over sine divided by sine over cosine. And yep, keep, change, flip tells us that this will change to cosine over sine times keep, change, flip. The cosine's here, and then the sine is here. Now these don't cancel because they're still up top, and these are still up top, but we know that this cancels, or not cancels, but reduces to something that looks like cosine squared and sine squared. So we'll have minus cosine squared over sine squared. Now with fractions, especially when we're adding or subtracting, we do want a common denominator, which you can see that we have right here, so that we can combine these two fractions to be one huge fraction altogether. Okay? And we know from our identities formula chart that here is a manipulation. It's a manipulation of this equation, right? Let me go ahead and bring it back. This one right here. We know sine squared plus cosine squared is 1. So back here I was saying 1 minus cosine squared is something. Well, let's manipulate this by subtracting the cosine over to the right, the cosine squared. That means sine squared is left on the right. So all this can now be replaced with sine squared. Okay? And yes, that common denominator that we got from before is still there. And those will cancel, reduce to another form of 1. Okay? So we know that cosine is an even function. And we know that sine is an odd function. And cosine means opposite inputs yield the same output. So that means this could also be written as cosine of z. Okay? So that stays the same, nothing's there. So these are these co-function ones that are on your identities formula chart. So down here, or these odd and even identities is what I meant to say. We just did the fact that cosine of a negative input, which is right here, is going to be the same as cosine of x. So this cosine of x is that substitution that I'm replacing over here as cosine of z. Now sine is odd, and if you see the sine of a negative input is also going to be that opposite output. So opposite inputs yield opposite outputs. You can see right here. Let me highlight it. Opposite inputs yield opposite outputs. Okay, so now I can replace that sine of negative x with a negative sine of x. So that right here will become a negative sine of x. And since we're adding this negative, we can say it's the same as subtracting sine of x. Okay? So subtracting sine of, let me change that variable to z. Okay? So now it's just basic algebra as far as sine minus sine. That cancels to a form of 0. So all you're left with is the cosine of z. So knowing how to use your identity formula charts, especially with even and odd substitutions, and then canceling and reducing gives us our 4 answers of tangent, 1, 1, and cosine of z.